Welcome back. Today we're digging into a super high-performance part of the StatsX system, the status instance.
So here's the plan. We'll look at the problem it solves, how it's born, what it's made of, and why it's so fast.
So how does a game track something like Poison for 30 seconds without lagging? It's a huge performance problem.
The slow way, make a new object for every single effect. The StatsX way is much smarter.
And that solution is the F-status instance. It's a special structure that holds all the important data for an effect.
But here's the crazy part. Most of the time, you don't even need one of these instances.
It's called inline execution. For simple effects, the code just runs and it's done. No persistent state needed.
An instance only gets created when things get complicated, like with durations, delays, or loops.
So execution starts simple. Then a handler says, hey, we need to save this, and migrates the data.
Okay, now for the anatomy. This thing is brilliantly designed, separating hot data from cold data.
That hot data section is exactly 64 bytes. Why? To fit perfectly into a single CPU cache line. This is the stuff that gets checked every single frame. Timers, state, stack count, all the critical bits.
And the cold data? That's the stuff you only need once in a while, so it stays out of the way.
An instance has a simple life. It's active, maybe it gets suspended, and then it's terminated to be reused.
But terminated doesn't mean destroyed. It just goes back into a pool ready to be used again.
This whole recycle, don't destroy approach is key. It avoids tons of memory allocation during gameplay. So the payoff comes from a few brilliant ideas: zero allocation, cache awareness, and creating instances only when needed.
It really makes you think, right? How much performance are other games leaving on the table?